Welcome to the video lecture on systems of nonlinear inequalities. In this section, we will learn how to solve systems of inequalities in two variables from a graphical point of view. The solution to a single inequality consists of a region whose boundary is the graph of the corresponding equation. To determine which side of the graph gives the solution set to the inequality, we need only to check test points. So we're going to start with trying to represent the solution to each of the following inequalities in two variables. Let's start with x squared plus y squared less than 36. Now the first thing you want to do in a case like this is graph the boundary. And to do that, just consider this as an equation. So ignore the inequality, put in an equal sign, and graph what that curve would look like. Hopefully you recognize that this is just the equation of a circle because it has an x squared and a y squared. The coefficients are both 1. There's no shift involved because there's no parentheses, so the center is at the origin. And the radius is the square root of this number on the right side. So the radius is 6. So what we want to do for our circle is plot a circle with the center at 0, 0. And then we're going to go out 6 to the right, 6 up, and 6 down and left. Now before I draw this circle, should it be a solid circle or should it be a dashed circle? You want to know that before you start drawing it in. And because this is strictly less than, this needs to be a dashed circle. If I had seen that little equal bar underneath, then it would be solid. So I want to draw a dashed circle of radius 6, something like this. Okay, not very circular, but use your imagination there. Now that's just the boundary. The next thing we need to do is figure out which side of the circle is our solution. And in this case, because it's a closed circle, we're only going to have for our answer the points on the inside of the circle or the points on the outside. And to figure out which one it is, we need a test point. So our test point here can be any point whatsoever. Usually I like to use the origin if I can, and the way you can tell whether or not you should use it for your test point is, does it lie on your curve? And as long as it does not lie on the curve, you can use it for your test point. So 0, 0 is in the middle here. It's not on the actual boundary of that circle. And what I'm going to do to test it is plug in 0 for x and 0 for y into the original inequality. So if I plug in those zeros, 0 squared plus 0 squared is still 0. Is 0 less than 36? Yes, that's a true statement. So here's the origin. It works, so we want to shade it in. And since it's on the inside of the circle, that means we must be needing to shade inside the circle. So this graph would be your answer. Okay? Let's try another example. This time we have y less than or equal to x squared minus 3. So first we want to graph the boundary, which we're going to do by creating an equation out of this. And this, hopefully you recognize, is just a parabola because it's got a y to the first and an x squared. And because there's that minus 3 on the side, that's a shift down 3 units. So it's our normal parabola, but instead of having the vertex at the origin, now the vertex is down here at -3. And then my pattern from there would be over 1 up 1, because there's no vertical stretch or compression, and then over 1 up 3. Just to get a couple of nice side points. Should this be a solid or a dashed parabola? This time it's going to be solid because I see that inequality bar. So we're going to do a nice solid parabola like this. And then either our solution will be inside of the parabola or outside of the parabola. So we're going to need to pick a test point again. And the origin does not intersect that parabola, so I'm going to use the origin. I'm going to plug in 0 for y and 0 for x. So this would become 0 less than or equal to 0 squared minus 3. 0 squared minus 3 is -3. Is 0 less than or equal to -3? No, that's false. So since that origin was in the middle and it doesn't work, you want to shade the other side of the curve, which would be the outside. So our final solution would be the graph that looks like this. Now, when you have a system of inequalities, that just means you have more than one. So you're going to graph your two inequalities on the same graph, and your final answer will always be the intersection of those two regions, or those two or more regions. So let's take a look at this system, and you'll see that it's a system when you see these curly braces. Let's start with the first equation. I'm going to make it into an equal sign, and that is a circle again because it has x squared plus y squared. So we're going to want to draw a circle. The center is at the origin, the radius is 5, and because there's no equal bar, I want to do this as a dashed circle. So I'm just going to have a circle something like this. Okay, now before we move on to the second one, let's go ahead and do our test point. So our test point would be, again, the origin would work for us since it's not on the circle, and I'm going to plug it into the original inequality. 0 squared plus 0 squared, is that less than 25? And yes, that's true. So I'm going to use a lighter color here temporarily, but so far that's what our graph would look like, the inside part of that circle. Now let's go ahead and take a look at our next inequality. This time, if I make it into an equal sign, this is a line because it's x to the first and y to the first. Now you can solve this or graph this any way you like. I like to just use my zeros, my intercepts, when it's just in this general form. So if I let x be 0, when does 2y equal to 5? When y is 5 halves, or 2.5. If I let y be 0, that forces x to be 5. So I get my two intercepts very quickly. 0, 2.5 would be right here, and 5, 0 would be right here. And this does have an equal bar, so I want a nice solid line. And then when I go to test here, we're either going to be shading above the line or below the line. So if I test a point, and I'm going to use the origin again because that's below the line, plugging it into the original inequality, 0 plus 2 times 0 stays 0. Is 0 greater than or equal to 5? No, that's false. So according to this, since the origin is below the line and it didn't work, then I would want to shade above. So it would look like that. Now your final answer should be the intersection of these two regions. So it needs to be the part of the graph that's above this line but still inside of my circle. So it's just going to be this little piece right here, this little sector right here. And that would be your final answer. Okay, so let's try another one. It looks a little bit more complicated, but it's not too bad really. We have 4 inequalities this time. Let's start with the first one. It's simpler than it looks because it's just x. X greater than or equal to 0. Now think about what x equals to 0 would look like. If you were just to graph that equation, whenever it's just x equals a constant, that's a vertical line. So this is just a vertical line through 0. In other words, it's just that y-axis. And if we have an equal bar, which we do, we want a nice solid vertical line right along that y-axis. Now here you probably can get away, hopefully, without doing a test point, because just think about the inequality. When is x going to be greater than or equal to 0? Which side of the line is greater than 0? This side, to the right. Okay, so there's the first one. Now let's move to the second one. If you were to make this just y equals to 0, y equals to a constant is a horizontal line. So again, it's a nice solid horizontal line right through the x-axis this time. And where is y greater than or equal to 0? When is it greater than 0? When you're going up for these positive y values. So it would look something like this. Now to remove some of the clutter from the graph, you don't have to do this, but hopefully you can see so far between these two regions, where do they overlap? Just in quadrant 1. So if it gets too confusing with all these pictures and scribbles on your graph, you can take away some of the pieces that aren't going to be in that final solution. And just realize so far here that whatever answer we come up with, it needs to lie just in quadrant 1 based on these first two inequalities. Okay, let's go ahead and do the third inequality. As a line, it would be x plus y equals to 10. So if I make a little table, when x is 0, y is 10. When y is 0, x is 10. So we have a couple of intercepts at 10 on the x-axis and 10 on the y-axis. And there is no equal bar here, so this will be a dashed line. And if I use a test point of 0, 0 into the original inequality, 0 plus 0 less than 10, is 0 less than 10? Yes. And since the origin lies below this line and it worked, then I would want to shade down below here. And keeping in mind what we said about being restricted to quadrant 1 and to make this not too cluttered, you can add in some of that shading so that it's just so far within this quadrant 1. So it would be that triangle that we have so far. Alright, finally the last inequality. If I make it into an equation, we get x squared plus y squared equals to 9. That's a circle again with a radius of 3 and a center at the origin. So here's 3, 3 to the left and 3 down. So this is going to be a dashed circle looking something like this. And then we'd want to pick a test point like the origin. X squared plus y squared greater than 9 becomes 0 squared plus 0 squared greater than 9. Is 0 greater than 9? No, that would be false. So we would want to shade outside of this circle. So that's what we would have just from that piece of it. So finally, putting it all together, we know we want to be restricted to quadrant 1, so I can't be any of these pieces here. And if I'm in quadrant 1, not only do I need to be in quadrant 1, but I need to be outside of the circle, but inside of this triangle, in other words, below this dashed line. So which piece of this is below the line, but outside of the circle and still in quadrant 1? It's going to be this region right here. And so make sure on these, on a test or whatever, that you're really darkening in that final solution that you have. The intersection points of the solution set are called vertices of the solution set, and the vertices may or may not actually be part of the solution set depending on whether or not the boundaries are included. And the vertices are found by finding the solution to the systems of equations. So if you really needed to find some of these intersection points like here and here, these you can probably just tell from the picture because these are the intercepts of the line and the intercepts of the circle. So this would be at 3, 0, 0, 3, 0, 10, and 10, 0. But those 4 points are called your vertices. And in some applications, like when you watch the video lecture on linear programming, those vertices can have an important role in the problem. So if you weren't able to see them from the graph or from your tables, then you would need to find the intersection between the two curves wherever they might occur. Alright, that concludes our lecture on systems of nonlinear inequalities. Good luck.